Okay, so we're looking at a video for preparing for the test in term 4 on the calculus of log functions or leading to log functions. So we've got 9 pages and also includes the application of the log. So as normal, just press pause, have a go, when you're ready, come back live. Okay, so the first one, pen, come on pen. Okay, so we've got y dash equals, the derivative of the function is 7, the function is 7x, and then just cancel down. Okay, next one, the derivative of 3 minus x is minus 1 divided by the function 3 minus x, and leave it like that. It's not wrong if you want to get rid of the negative sign and switch the bottom, but both answers are okay. Okay, so let's move on. Okay, so another one, again, just remember you've got some other rules you need to apply. Okay, pause, and when you're ready, come back live. Okay, so we've got two things with a multiplier, so we have to use the product rule. So u equals x, u dash equals 1, v equals log 2x, and v dash equals 2 over 2x, which is 1 on x, so therefore y dash equals, so with the product rule, you do your cross in between. So you got x times 1 on x is 1 plus 1 times log 2x, and that's your answer. Okay, next one, before you can do it, you've got to turn it into a power, and now we're going to use the chain rule. So y dash equals multiply by the power, write the bracket, subtract 1 from the power, and multiply by the derivative, which is 1 on x. So we end up with everything on the bottom. So the 2's on the bottom, the x is on the bottom, and the log x is on the bottom with a square root sign. So we've got 2x and then log x to the half. Or if you wanted to, you could put 1x root log x, but I like that answer's better. Okay, let's move on. Next one. Okay, so again, just look at your rules and have a go when you're ready. Okay, so this one we've got a quotient. So we've got u equals e to the x, u dash equals e to the x, doesn't change, v equals log x, v dash equals 1 on x. So the derivative equals v times u dash minus u times v dash over v squared. We can take e to the x out, so we've got log x minus 1 on x over log x squared, and that's pretty untidy because you've got a fraction inside a fraction. So what we'll do is we'll multiply everything inside the bracket by x, so we end up with x log x minus 1, and then the x comes to the bottom. Okay, that's pretty straightforward. Next question, I can't see what it is. So we've got, first thing you do is you've got to bring the square root out, and so y dash equals, so the derivative of the function is a half, 1 minus 2x to the minus a half multiplied by the derivative of the bracket, which is minus 2. Okay, so we've got, that's f dash x over fx minus 2x. Okay, so on the top line we've got the derivative of the bracket, which is a half multiplied by the power, leave the bracket, subtract 1 from the power, multiply by the derivative. Okay, a half and minus 2 make minus 1, and then that can come down the bottom and join with that one to make a whole. So the answer is minus 1 over 1 minus 2x, or if you wanted to, you could switch the signs and make it a plus on the top. Okay, let's move on. Okay, so sketching a log function. Okay, you can do any method you like, table of values, whatever you like, and have a go. Okay, so we're back. So the normal log function looks like that. Okay, so it doesn't normally have a y-intercept, but it has an x-intercept. So let's calculate the x-intercept first. So the x-intercept, which is when y equals 0. Okay, so we've got 0 equals log 2x plus 4 minus 1. So log 2x plus 4 equals positive 1. And so that's the indices. So e to the power of 1 equals 2x plus 4. So 2x equals e minus 4. So e minus 4 over 2. And that's going to be a negative number. So basically what's happening is the function is being shifted that way, and then it's going to be dropped 1. Okay, so if you wanted to have a look, this number here, e minus 4 over 2, let's just approximate what it looks like. I can get my calculator out. So, not e to the 1 minus 4 divided by 2. Okay, so it's approximately minus 0.6. So it's definitely a negative number. Okay, so it's going to go up like that. Oh, change colour. So now it's going to have a y-intercept. So the y-intercept, which is when x equals 0, so we've got y equals log 4 minus 1. And that's approximately, what's that equal to? Log 4 minus 1 equals, so it's approximately 0.4, but the exact value is log 4 minus 1, and that value is exactly e to the minus 4 over 2. Don't forget to label your axes, and we're done. Okay, let's move on. Okay, so finding an equation of a tangent or normal, they're sort of questions you need to be able to do. So pause, and when you're ready, come back live. Okay, so the first thing we do, you're back, is find the derivative. So we've got minus 1 over 2 minus x, or if you wanted to, switch the signs, which I'm going to. Okay, so at x equals 1, y dash equals 1 over 1 minus 2. So the gradient is minus 1. We need to find the y value, so at x equals 1, y equals log of 2 minus 1 equals log of 1 equals 0. So we've got y equals mx plus b, or you can use y minus y1 equals mx minus x1. Doesn't matter which one you use, I'll use this first one. So we've got 0 equals minus 1 times x is 1 plus b. So 0 equals minus 1 plus b, so b equals 1. So the equation of the tangent equals y equals mx plus b. So we've got minus x plus 1. So that's the equation of the tangent. Again, if you're doing the normal, you just have to flip that number there and then still do all the steps the same. Okay, so now we're doing integration leading to logs. So have a go. When you're ready, come back. Okay, so again, depending which way you want to do it, I'll just take, first thing I'll do is I'll take the 7 outside. Okay. And then we say, well, what number do we want on top? We want a 2, so we have to balance it with the 2 out the front. And so the answer is 7 over 2 log 2x plus c. Don't forget it's the plus c. Okay, so taking shortcut, the derivative of the denominator is 2x. So we need to put a 2 there, and then we balance it with a half out the front. And so the answer is a half log bracket x squared plus 1 close bracket plus c. Don't forget to put it in brackets. If you write a half log x squared plus 1 plus c, I will penalise you because that is not written correctly, because that implies that only the log is being x squared, only getting log of x squared. So that's wrong. Don't forget. Okay, moving along. Okay, so we've got a couple of, rather than values not known, we're going to find some values. So we're going to get definite integrals rather than indefinite integrals. Okay, pause. When you're ready, come back live. Okay, so the first thing we need to do is we need to break that up into 2 fractions. So we've got 2x over x plus 5 over x dx. So 2x over x is just 2, and that's still going to be 5 over x dx. I didn't, e cubed e. So the integral of 2 is 2x. The integral of 5 over x, taking a shortcut, is 5 log x, e cubed e. So now we can put the values in. So we've got 2e cubed plus 5 log e cubed minus, and then 2e plus 5 log e. Okay, so we've got 2e cubed, so log e is 1, so that 3 comes out the front, so it's 15. Yep. Minus 2e, log of e is 1, so we've got minus 2e and minus 5, and so the answer is 2e cubed minus 2e plus 10. I think that's the answer, so if I've made a mistake, let me know in class. I think that's okay. Okay, next one. Okay, so the function is cos x, so sine goes to cos goes to minus sine, so the derivative of cos is minus sine, and so we need to take the 2 outs to start with, put a minus on top, and then put a minus out the front to balance it all off. 0 pi on 6 dx. Okay, so now we've got the function on the bottom and got the derivative on the top. So the answer is minus 2 log cos x from 0 to pi on 6. So we've got log, so cos of pi on 6 is root 3 on 2 minus cos of 0 is 1. So we've got log of 1 is going to be 0, and so we end up with minus log root 3 on 2, and just leave it like that. That's the exact value. Okay, come across when you're ready. Okay, so one of these ones, again, you've had plenty of practice where you derive something and then hence find something else. So can you have a go at that? Don't forget, you've got to use one of the rules. Okay, we're back. It's a product we have to do. I forgot to put the e there. Sorry. B dash is 1 on x. So the derivative equals 1 log x, which is log x plus x times x. 1 on x is 1. Okay, and that's the derivative. Okay, and again, you've had plenty of practice with these ones. So we've got e squared. Again, I forgot to put the e there. So we've got log x. Now, I need log x plus 1, so I add 1 and I subtract 1, and then I haven't changed the question. So then we've got e squared log x plus 1 minus e squared 1 dx. Okay, so we're just breaking it up into 2 parts, and then put the integral sign with both of them. And then log x plus 1 is log x plus 1, which means it came from x log x between e and e squared, and then 1 is just going to be x between e and e squared. So we've got e squared, I'll take it back to log e squared minus e log e, so that's the first bracket, minus second bracket will just be e squared minus e. Okay, log of e is 1, so that's going to be 2e squared. Log of e is 1, so that's just going to be e minus e squared, and then minus and minus is a plus, so it's just plus e. Those two cancel out, so I think the answer is just 2e squared minus e squared, so I think the answer is just e squared. Hopefully that's okay. If I made a mistake, let me know. Come across when you're ready. Okay, so our last slide is these applications, which is just this last thing. So again, just check your notes for these sort of questions and have a go when you're ready. Okay, so we're back. So the difference intensity is going to be 10 to the power of the difference, to 10 to the power of 1.5. And on your calculator, find tens. Yep, I got it. Inverse 10, 1.5. So it's going to be 31.6 times larger. Okay, so difference in intensity is 31.6 times larger. Alright, next one, again, is just those formulas. I'm going to get my formula out. So we've got log of the energy is going to be 4.8 plus 1.5 times 3.5. So on your calculator, 4.8 plus 1.5 times 3.5 equals 10.05, and so the energy will be 10 to the power of 10.05 joules. Okay, England's function 10 to the power of 10.05. So it's 1.12 by 10 to the 10 joules. Okay, so to 2 decimal places. Okay, that's it. Hope you enjoyed. Bye.